and welcome to our lesson for today. We're going to go over solving with proportions. So if you missed the last video going over rates, ratios, and proportions, you can catch that link below. And if you need to watch that video first and come back, that's fine. We're going to start out with a few definitions just to kind of relate everything. So the first one we're going to talk about is similar shapes. So this is where they have the exact same shape but different sizes. So anything such as a square. So a square, no matter what size it is, no matter what the measurement of the sides are, all squares are the exact same shape, they're just different sizes. So those are going to be similar shapes. Corresponding sides and angles is where we can take that shape and we can tell you that the triangle, for example, triangle ABC, if it is similar to triangle DEF, then we can determine a couple of things here. So let's go ahead and just draw these out real quick. And I'm going to draw these so that they're not exactly in the same position. So triangle ABC is similar to DEF, which means several things. So we can actually determine a few things from this. We can determine that line AB is proportional to DE. Two reasons I can figure this out. One, from looking at the picture, because they're the same line in the actual triangle as far as the similarities, but I can also tell because AB is the first two letters here, and DE is the first two letters on this triangle. So I know that those are proportional. So continuing on, I can also say that BC is equal to EF, or proportional, excuse me. And then I can also say that AC is proportional to DF. All right? Now, another thing we can determine is the measurement of our angles. So the measure of angle A is equal to the measure of angle D. The measure of angle B is equal to, you guessed it, the measure of angle E. And the measure of angle C is equal to the measure of angle F. So all of these can be determined just by being given this information right here. The triangle ABC is similar, that's what this symbol here is similar to triangle DEF. I can determine all of this. So using this information, we can actually make a proportion to solve for missing side lengths. So let's go ahead and do a couple of examples so that you can see how to actually use this to solve those problems. So we're going to start out with, again, triangle ABC is similar to triangle DEF. So we'll go ahead and keep things the same here. So if I have my triangle A, B, and C, and then here I have D, E, F. Notice it doesn't matter if they're drawn exactly the same or in the same position. As long as you have this statement right here, then we know that side AB is proportional to DE. So let's go ahead and fill this in and we can solve. So AC is 5 inches, AB is 8 inches, DE is X inches, I don't know what that is, and DF is 18 inches. So I can go ahead and set up my proportion here in order to solve for this missing side. So here's what I'm going to do. I'm going to do DE is X, which is equivalent to AB, which is 8. So I can put those one over the other. I can also then say, now, X is on the same triangle as 18, so I have to keep those either together on the bottom in the denominators or on the same side of the equal sign. And I'll go over a couple of different ways to write this in a minute, which means 5 inches is the other known there that I can put that place. So I can either do sides that are proportional, one over the other equals the other triangle, or I can do one triangle, so I can say x over 18 is equal to, well, x is proportional to 8, so that would go on top, is equal to 5. Now watch what this does, and I'm going to show you here in 2 different colors so we can see it easier. So if I'm going to solve this with a proportion, I would say 8 times 18 equals 5 times x. Now look down here. If I were to solve this one, I would say 5 times x is equal to 8 times 18. So notice that even though in this first problem we put proportional sides on one side of the equal sign and the other proportional sides from the other triangle there, or from different triangles, and this one we put sides from the same triangle equal to sides from the other triangle. So it doesn't matter which way you write it. If you want to do this triangle over this triangle and then equal to this side over this side, or if you want to say this triangle x over 18 is equal to 8 over 5. What matters is that you keep your sides proportional. So if I'm comparing AB to DE, that either has to go one on top of the other or across from each other. So you have to keep everything together. So now let's go ahead and solve this problem here. So 5x equals 8 times 18, which is 144. Next, I'm going to divide both sides by 5. And so x is left on this side. And x equals, so now we're doing 144 divided by 5. This goes in 2 times, bring down my 4, goes in 8 times. I have a remainder, so I'm going to put in a decimal, bring down a 0. So my answer is 28.8. And that is inches. Make sure you label. All right, so now I figured out that this missing side length is 28.8 inches. So proportions are going to help you in a great way figure out unknowns, especially when it comes to shapes. So let's try one more. All right, so now I'm going to say that RSTU is similar to ABCD. So now we're dealing with a four-sided figure. So in this case, we're going to go ahead and draw it. Not perfect, but there you go. So this one is going to be ABCD. And you'll notice that things go around in order. Okay? So on this one, RS is X feet. UT is 24 feet. AB is 5 feet. And DC is 4 feet. So let's go ahead and set up our ratio, or our proportion, excuse me. So we have two ratios. So the first one, I'm going to do 5 over 4 equals X over 24. Notice on the same side of the equal sign, I kept the shapes together. So I did ABCD on this left side, I did RSTU on the right side, and then the numerators are the long side, and the denominators are the short side. So we have to keep everything proportional. All right, so let's go ahead and solve this one. So we are going to do 5 times 24, which is 120, equals 4 times x, which is 4x. And then my last step I have is to divide by 4. So x equals 35. feet. So that means that this missing side right here is 30 feet. If you want to see more videos on proportions, you can check out the links below. We're also going to have a video going over practice with these proportions, and especially the ones where we have a sample of something that needs to find a missing side or a missing length or a missing height, whatever the case may be. So join us again on that video. You can find it linked below. If you like this video, give us a thumbs up, and don't forget to subscribe and share us with your friends and your parents. And we hope you guys have a great day. Bye.